Okay, so I'm gonna continue with the 8051 instruction set. Now, these are rotate instructions. So there's rotate left, rotate right, rotate through carry, rotate left or right through carry. So I think I mentioned this before, right? So rotate means it's like shifting, except the bits that fall off will come in on the other side. The through carry version means instead of putting from the most significant back to the least significant or least significant back to most significant, you go through the carry. Okay, and so I think we talked about this one before. So why would you need to move something through carry? Well, one thing is it's a way for you to transfer the bits between accumulator and the carry bit, right? Because remember, the carry bit is used for like the jump if carry is set or carry is not set. There are other uses of it too. So it's a convenient thing to do. And also carry, unlike shift is lossy in that after shifting, some bits drop off. You fill in zeros or you fill in the sign bit or something, but not with carry. With carry, or not with the rotate, you preserve all of the bits. So that way you can restore back without having to save them in some temporary place. Okay, here is an application of the rotate left or right through carry. Uh, the, this little program will count the number of bits in the byte. Does that make sense? So your byte consists of zeros and ones. How many ones are there in your byte pattern? Well, this is one way to do it. You can first initialize R0 to be 0, and that's your count. And then you can put the bit pattern in there. And of course, it doesn't have to come from the constant 23 hex. It could be input from some other source. It could be the serial port, it could be your IO port or something, right? But here, just for testing purpose, we put in hex 23. And hex 23, well, you know it looks like 0010, 0011, right? So there are three ones in the bit pattern. But anyway, how does a program know how to do that? Well, what you can do is to then rotate the bits, right? And you can do the rotate uh, uh, through carry. So, well, first you have to know how many times to loop. So you use R1 as your loop counter. Set it to 8, and then in the loop you do rotate left through carry. So you take what's in the accumulator, shift by one position to the left, and the bits from the most significant bit goes through the carry. The carry gets fed back to the least significant position. So that's rotating. And then if it's so it does the JNC, the jump if the carry bit is 0. Uh, so so that means it does not increment if it's 0. Otherwise, it falls through and increments it. Right? In either case, you're at skip and then DJNZ. Remember that? Decrement jump if not 0. Right? So decrement the count, which is R1. Jump back to the loop if it's not 0. So it rotates the through carry. You test carry each time, and this is how you can count the number of ones in in the uh, in the byte. There are other ways to count number of ones in the byte. I think the inventor of C programming language, so I forgot if it's Kernighan or Ritchie. They actually got a very clever algorithm for counting number of ones. You can probably find this online. Of course, but if you don't know that algorithm, then this one is probably an interesting one to try. Okay. Okay, now there's the swap instruction. I think I also mentioned it a little bit. Swap looks like swap, and then A. As you know, A is implicit. It's hard coded in the opcode, and it swaps the half bytes inside A. So A is a single byte, has a lower byte or lower half byte, which is called a nibble, and higher nibble. It switches the two. So if you have something like hex 2-3, after swap it becomes hex 3-2, right? So why would you want to do that? Good question. Depends. I guess there are times when, well, I guess one thing is in relation to rotate. Rotate allows you to rotate only by one bit position, at least in 8051. Unlike many other architecture instructions, you have a shift, which actually allows you to put the number of positions to shift. Here, no, it actually, the rotate only rotates by one position. So this is kind of a shortcut in that you can rotate 4 times, right? So that's essentially what a swap. And it really doesn't matter if you rotate left or rotate right. They're going to come out exactly the same. Okay, so swap is like rotating either direction without going through the carry 4 times. And so with the combination of rotate and swap, I think you can make the shifts or rotating a little faster. So if you want to rotate 2 positions, you do 2 rotates. 3 positions, you can do a swap by rotate in opposite direction, right? Right. So for example, if you want to rotate to the left in 3 positions, you don't have to do rotate to left 3 times. You do a swap and then rotate right. That's like rotate left 3 times, right? Because it's +4 - 1. That's 3. And to do rotate 4 times, you just do swap. Okay. So there are potentially other uses of swap. So extracting nibbles, that's I think one possible use of the swap instruction. And really, I think that more specifically, this has to do with the binary coded decimal, BCD. And I think I have slides in the next set, not this set, but next set after GPIO, to talk about the BCD a little bit more.